Here we are on to page 3. This is going to put together some things that we have done the last couple of days and show you overall what we use data for and different types of data. So this title up here, I have interpreting and using data. I have also numbered this as page 3. You should pause as necessary to get that taken care of on your page 3 as well. This page is where we're going to start investigating the data that you guys gave me when you filled in the Google Forms before spring break. And you'll see how many people actually filled it out. I messaged it to you and I left it up for that school day, and then I took the data from there. So a few of you probably answered after, but we're going to go with the data I was able to gather by the time I made this video. So one of the questions I asked you on that Google form is, what is your favorite season? So check this out. Make sure you set it up the way that I do so that you can fit everything you need to. I'm going to put favorite season right here. And then on the other side of this red line, so on the red line, I'm going to come down 4 spaces. And then I'm going to draw another line over here that comes down 4 spaces. And then I'm going to draw this across here and this across here. And in fact, now I'm going to go all the way across here and draw another line across here. This is where I'm going to put the 4 seasons that I asked you about that exist in our world. We have winter. We have spring. We have summer. And of course, fall. I'm going to give you the results of that survey. I'll draw another line right here because it looks weird without it in just a moment. But first, here's how we're going to set this up to fit this on the other side. I'm going to come over here on the other side of this red line, up above the first blue line. I'm going to write eye color. This is another thing I asked you about. And I listed in there all the possible eye colors. There's a couple other weird variations, but I asked you about the most common ones in the world because most of us fit in that. We have blue, and I'm going to write this on the other side of this. So let's draw some lines here to guide ourselves. This needs to go down 1, 2, 3, 4, 5, 6 spaces right to there. There were 6 options I gave you there. So we have blue, we have brown, hazel, amber, amber eyes, green eyes, or gray. Okay, those are the 6 possibilities. And I'm going to draw a line across the bottom here. I'm going to draw a line across that right there, and then draw a line down right there. Okay, now that we've got those tables all set up, now I can give you the results of the survey. You ready? Ta-da! These are the number of responses in each category. Okay, 2 of you said you like winter best, 15 said spring, 28 said summer, and 6 said fall. Likewise, here's all the data from the eye color. As always, pause if you need to write that down. This kind of data has a name. And I'm going to write the name up here in a fun, fancy font. You don't have to write it fancy. You can if you want. I just like to. The word is categorical. C-A-T-E-G-O-R-I-C-A-L. Yep, I read it in funny font. Categorical data. This is an example of categorical data, and this is an example of categorical data. Why is it called categorical data? Well, because I just gave you categories to pick from. I said, what's your favorite season? And then I gave you choices, and then I just categorized your answers. I said 2 people said winter, 15 people said spring, 28 said summer, 6 said fall. It's categorical data because it's in categories. This is also categorical data because it's in categories of eye color. Which eye color are you? Pick one. Okay, so this is categorical data. The other thing we're going to do, I'm going to write some words here. Right about under that I in categorical data, I'm going to start writing sample size. I'm going to write this ... For the favorite season, can you find out for me the sample size? In other words, how much data did I get? How big was my sample? In other words, how many people responded to the Google Forms survey? Well, to find that, all I have to do is add those numbers up, right? 2 plus 15 plus 28 plus 6. I'm going to add up those numbers. The sample size is 51. 51 of you responded to it in the short amount of time I gave you. I only left it open for a few hours. So 51 is our sample size. And I'm going to make this just for fun. I'm going to make it a little, I'm going to actually go like this. I'm going to make a speech bubble like this. That sample size was 51. Now I'm going to write over here, I'm going to come down to about this line and I'm going to write it again. Sample size. What do you think should probably be true for this data? Should it have the same sample size? Well, yeah, as long as everybody answered the questions, then we should probably have the same sample size. But let's double check. 10 plus 28 plus 5 plus 4 plus 4. Oh, look at that, 51. So the sample size here was also 51. I'm going to make another. I'm going to go like this. Here's another little speech bubble. That's just a reminder that there's this thing called sample size, and sample size is how much data did you get? How big was your sample? My sample size was 51. Now, we keep saying sample, and remember that's a vocabulary word that we've worked on this week. Sample means a subset of a population. So there is one more thing I'm going to write over here. I'm going to tell myself what is the population that we are studying. Well, the question is, what is my sample? A sample of what? Oh, my sample was 7th graders. So the population I am studying, it makes sense to say I am studying only 7th graders. And this one, I'm going to make a thought bubble instead of a speech bubble, just because seems like a fun thing to do. Okay, so all this vocabulary, all this language here, this is real data that I gathered from you. I didn't make any of this up. You guys submitted your answers and I just categorized it. It's categorical data. Actually, I didn't even. Google Forms did it for me and I just wrote it on a piece of paper. Okay, so this is categorical data. I asked 51 of you. We are now going to answer some questions about this data. So the first thing I'm going to do is I'm going to come to the middle here. Let's see, 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to go 1, 2, 3, 4, 5, 6, 7. And right here, I'm going to make a little squiggly across so I know how much space I'm dealing with. So I just counted down 7 lines. It's right above that middle 3-hole punch. Okay, and then I'm also going to put a squiggly right about down the middle here. And I'm going to ask you, that's not very, I mean, it's squiggly, but it's also wonky. That's okay. It's fine. I'm going to ask you 2 questions about this data. All right, here's the 2 questions. I will read them to you. You get them written down. Question number 1, if there are 237th graders at Riverview, which is a true statement. There are currently 237th graders registered at Riverview. If there are 237th graders at Riverview, how many can we predict will like summer best? Okay, and question number 2, if there are 542 7th graders in all of Murray, okay, and I'm going to be honest right now, that one's about a guess. I don't know that one for sure. How many can we expect to have gray eyes? This is what we practiced a little on the last page. We are now going to use our sample data, our sample of 51 7th graders to make predictions about larger populations, okay? So this is where we're going to use proportional reasoning. In our sample, how many said that they like summer the best? Well, look up in the table. The data's right there. In our sample, 28 out of 51 said that they like summer best. So we're going to say, here's what happened in our sample. What is going to happen in the population? Right? This is what happened in the sample. What's going to happen in the population? 28 out of 51 equals what out of 230? So now I'm cross multiplying. 28 times 230 is 6440 equals 51x. I'm going to divide both sides by 51. Now in my calculator, look what it says. It says this. Now I'm talking about seventh graders, so I'm going to round that to the nearest whole because all people are whole people. So we're going to predict that about 126 seventh graders at Riverview, and I'm not going to have room to fit all of this, but I'm going to predict that 126 of the seventh graders at Riverview would like summer. So if I went and asked every single seventh grader at Riverview, it should be close to that if our sample is accurate. Now, does that mean it's going to be exactly 126? No, but it would probably be close. You could ask everyone and find out. Now this one, what if there are 542 seventh graders in all of Murray School District? How many can we expect to have gray eyes? Once again, start with your sample. So take a look at our sample. In our sample, 4 out of 51 had gray eyes. What is that going to be out of 542? This is again us using a sample to make predictions about a population. 2,168 equals 51x. I'm cross multiplying, so I'm going to divide by 51 right here in my calculator. It says 42.5. I'm going to round that up to 43 seventh graders. And I could go through and I could ask you this question about any of them. I could have said, okay, if there's this many in Murray, how many would we expect to have blue eyes and brown eyes and hazel eyes? And this is pretty much all you can do with categorical data. Categorical data, when you're asking a question that involves different categories and people pick a category, then all you can really do at that point is use it to try to make predictions. Okay, what we're going to start moving into, and this is important data, this is useful data, right? That's like, it's like the senior class president trying to find out which senior class party people want. She gave them options. They picked an option that's categorical, that's useful. She wants to know that. Sometimes though, this type of data is more useful. So again, this top half over the squiggle line is all about categorical data, categorical data. The other kind of data that we're going to work on for the next few days is called, and I'm writing it right here on this line, numerical data. We have categorical data and we have numerical data. Well, categorical data is data in categories. So what do you think numerical data is? Well, it's data with numbers. Okay, so numerical data, we gathered some of that too. I asked you for some numerical data, and we're going to not only go over the data that you got, but we're also going to review a display that I'm pretty sure you created before 7th grade. I'm pretty sure you've seen this before, but here's what we need. We need 1, 2, 3, 4, 5, 6, 7. I'm going to go 7 spaces down. You ready? Counting with me? Okay. 1, 2, 3, 4, 5, 6, 7. Below that 7th space, I'm going to make a number line. And the number line really doesn't need to go all the way across. That's probably enough. Because this numerical data is going to come from the question that I ask you. When I ask you a question like, what's your favorite season? That's got to be a categorical answer. When I ask you a question like, how many pets do you have? Or how many siblings do you have? Now we're talking numerical data. So let's focus on that data where I asked you, how many siblings do you have that live with you? That's what I asked you, that live with you. I'm just curious about how many siblings are still living at your house. So when you say siblings, you didn't count yourself, right? That's why if no siblings live with you, you put a 0. That means you're the only child at your home. Okay, so I'm going to put some scale markings. The lowest answer was, of course, 0. And the highest answer in our data was 6. So that means my number line only needs to go from 0 to 6. So here I go. And you want to space these out as evenly as you can. So I'm going to go 1, 2, 3, 4, 5, 6. And that's all we need. Okay. What we are making is we are going to make something called a dot plot. So the other thing I want right down here is I want a label to tell me that these numbers represent, this was data about siblings living with you. Number of siblings that you live with. Now I went through and 51 of you responded. Okay. 51 of you responded to this. So that's a lot of data to kind of lay out and gather. So I'm putting it in this dot plot display. All right. Now what that means is that means that I'm going to take this, I'm going to use a different color. I'm going to use this purple marker, and I am going to draw dots to represent how many people answered in each category. So, and it's still, I just said the word category, but it's numerical data because you didn't answer. I didn't give you a list. I didn't say you have to pick 0, 1, 2, or 3. You could type in whatever number you wanted, but you were typing in a number. So you were giving me numerical data. It's data with numbers. So the other thing with the dot plot is we want to make this as even as possible. So for example, 4 of you said 0 siblings. So what I'm going to do is I'm going to start above this. I'm going to put a dot right on this line. And I'm going to tell you that that's always going to be like the third dot. So we're going to have one halfway and then between those. So that'll be 1, 2, 3, and then one more a fourth of the way up. I'm just breaking these spaces into fourths, if that makes sense. So 4 of you said you're the only one that lives at home. 1 was the biggest group and it was 16 of you. Okay, so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh, I squished it. I have to white out and try this again. Hold, please. Okay, clearly counting out loud and trying to level my dots was not working. So essentially what happens is you get 3 until you hit the next line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That third one should always land on a line. So the next highest was 2, and that had 13 people in that group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. I always get a little wonky. It's okay. So you can kind of think of this like sometimes you could put a scale over here to show how high these are. This is 3, 6, 9, 12, 15, and this would be 18 up here. So that can be helpful if you want to put that. I'm going to put the rest of the dots in and then you guys can copy them on. All right. So take a look. You can count the dots and put them on the right place. Here's the deal. If I counted all of the dots, and first I'm going to say this. Okay, this is considered, I'm going to draw an arrow down here because this is numerical data. Numerical data, this is data in numbers. If this had not been numerical data, a dot plot wouldn't really work because I need a number line down here to make a dot plot work. So one thing you can do when you have numerical data is you can turn it into a nice numerical display, like a dot plot. So I'm going to write a couple things over here to make sure my brain is processing what's going on. First of all, I'm going to write this again so that I remind myself there is still a certain sample size here. And the sample size is still 51, which means if I count up all of these dots, I will have 51 of them. Okay, there are 51 dots. Because my sample size is still 51, because I still asked 51 of you this question and 51 of you answered. Okay, so the sample size is 51. There's 51 dots on the dot plot. The difference is now instead of categorical data, this is numerical data. So I needed a dot for every single one of you to show which number you answered. Another thing I'm going to tell myself, I'm going to write another note over here. This display is called a dot plot. Just to remind myself of that. I believe you made some of those in 6th grade or should have, I don't know. I'm going to make this one a thought bubble. Okay, because that's kind of what I'm thinking to myself. So the sample size here is 51. This display that I just made out of this beautiful numerical data is called a dot plot. What else can you do with numerical data? Here's some really important stuff you can do with numerical data. I am going to draw a box right here. I'm going to do a line across here. And I need 1, 2, 3, 4, 5, 6 spaces right down here. That's only 5, so I need 1 more. And then I'm going to finish this box over here. And in this box, I'm going to give you some definitions And then we're also going to do some calculations with our very own data, the siblings living with you, okay? There are 3 things we are going to calculate with this. And I am quite certain that you've heard these before. There's the mean. We're skipping a line and then writing the next word. The next word is median. And skipping a line and writing the third word, mode. These 3 N's are known as the measures of central tendency. This is the beauty of numerical data. I can't find this stuff with values like categorical data. You telling me which season is your favorite, that's great. I can categorize it. I can make some predictions, but that's all I can do. I can't calculate things with it unless it's numerical data. I need numerical data to do mathematical calculations. Okay, so what are these things? Well, the mean is the average. The mean is the average. The median is the middle value. And the mode is the most common value. So to show ourselves what those mean, the average, I'm going to change to purple now. Let's actually find this information for the siblings living with you. The average means you have to add them all up and divide by the sample size. Okay, so I'm going to write in parentheses, or I'm actually going to write this. Find the sum and divide by sample size. How much data do you have? Find the sum and divide by sample size. Okay, so what that means is I don't just add up 0, 1, 2, 3, 4, 5, and 6. Every single one of these dots has to be added up. Every one of the 51 values has to be added up. So 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2, right? I have to add them all up. I've done that for you because I'm the nicest teacher ever. And when I add all these up, so I got 16 1, so that's 16, 13 2, so that's 26, right? 8 3, so that's 24. Does that make sense? I'm actually adding them all up and I got a total of 111. So the sum of all of them is 111, and dividing by the sample size means I'm dividing by 51. How many pieces of data are there? So 111 divided by 51 is 2.176. So that's about 2.2. I'm going to call it 2.2. 2.2 siblings. Obviously, you can't have 0.2 of a sibling, but I'm trying to keep it a little more exact so I can do some comparing. This right here is the sum of all of the data you gave me. Add up all the answers you gave me, divide by 51, and you get something called the mean. Okay, the average number of siblings for my 7th graders is 2.2 siblings. The median is the middle, which they have to be in numerical order for you to find the middle. And here's the good news. If you have a dot plot, they are in numerical order, right? They go in order, 0, 1, 2, 3, 4, 5, 6. So all I need to do is think about what's halfway of 51. What's in the middle of 51? Well, 51 divided by 2 is 25.5. You know what that means? The median lies exactly on a number. So halfway between, let's see. So what I'm going to do is count 25 dots from the bottom up. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. This right here should be the median. Just going to count and make sure there's 25 on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I got the exact middle dot. That means I found the median. And it's on 2 in this 2 column. So the median is 2 siblings. Okay, there's another kind of central value for our data. So last one is the mode. And what does the most common mean? Which one happened the most? Which one was the most common answer? In other words, which one has the tallest stack of dots? Well, that one is 1 sibling. Now, these measures of center, just kind of a central value, they represent my 7th grade students, okay? Because you guys are the ones that answered the Google form. So if I'm looking at all of those, can you guys give me one overall number that you think represents all of you? Which number represents you the best? overall final statement, looking at all this central information, I could make a general statement and say, Miss McGowan's seventh graders tend to have two siblings living at home with them. That's a very common answer. That could only be found because I have numerical data. Okay, so just to sum up, two types of data we deal with. Categorical data is data in categories, and all you can really do is say the most common stuff that was answered and maybe make some predictions out of it. Numerical data, we barely started. Numerical data is super useful because you can find all kinds of stuff from it. One set of things you can find are these mean, median, and mode. We're going to find a lot more of that stuff tomorrow.